A satellite is a body that orbits around another body in space. There are two different types of satellites, natural and man-made. Examples of natural satellites are the Earth and Moon. The Earth rotates around the Sun and the Moon rotates around the Earth. A man-made satellite is a machine that is launched into space and orbits around a body in space. Examples of man-made satellites includes the Hubble Space Telescope and the International Space Station. Welcome to Space Time with Pradishwaran and Alalaki Shanmugam from Fozercon. On 4th October of 1957, the Soviet Union launched the world's first artificial satellite, Sputnik 1. Since then, about 8,900 satellites from more than 40 countries have been launched. According to a 2018 estimation, some 5,000 remain in orbit. Of those, about 1,900 were operational, while the rest have lived out their useful lives and became space debris. So here's a little information about Soviet Union. Its name was Union of Soviet Socialist Republics, USSR. That was a federal socialist state in northern Eurasia that existed from 1922 to 1991. So the space race of the 1950s saw that Soviet Union and United States competing to send the first artificial satellite into orbit. By 1957, the first stage of the race had been won, with the Soviet Union launching Sputnik. Made possible by advances in technology, Sputnik was only the beginning, and since then, the number of satellites in orbit has been rocketed, with over 6,000 being launched in the years that have followed. So you guys might be wondering, who won the space race? The answer is United States. By landing on the moon, the United States effectively won the space race that had begun with Sputnik's launch in 1957. For their part, the Soviets made 4 failed attempts to launch a lunar landing craft between 1969 and 1972, including a spectacular launch pad explosion in July 1969. From a beginning to end, the American public's attention was captivated by the space race. The various developments by the Soviet and US space program were heavily covered in the national media. This frenzied interest was further encouraged by the new medium of television. Astronauts came to be seen as the ultimate American heroes and earthbound men, and women seemed to live vicariously through them. Soviets, in turn, were pictured as the ultimate villains with their massive, relentless efforts to surpass America and prove the power of the communist system. Satellites can be classified by their function since they are launched into space to do a specific job. The satellites must be designed specifically to fulfill its role. There are 9 different types of satellites, such as communication satellites, remote sensing satellites, navigation satellite, LEO, MEO, HEO, GPS, GEOS, drone satellites, ground satellite, polar satellite. Communication satellites are artificial satellites that receive signals from an Earth station and then retransmit the signal to other Earth station. They commonly move in a geostationary orbit. A remote sensing instrument collects information about an object. This is communication satellite, an artificial satellite that relays and amplifies radio telecommunication signals via a transponder. It creates a communication channel between a source of transmitter and a receiver at different locations of Earth. Next, this is a remote sensing satellite. So what is remote sensing satellite? Remote sensing satellite is a process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance. So here's some uses of remote sensing satellites. Large forest fires can be mapped from space, allowing rangers to see much larger area than from the ground. Next, tracking clouds to help predict the weather of watching erupting volcanoes and help watching for dust storms. Third, tracking the growth of a city and changes in farmland or forests over several years or decades. Fourth, discovery and mapping of rock topography of the ocean floor, example mountain ranges, deep canyons, and the magnetic stripping on the ocean floor. So this is the third type of satellite, which is geocentric orbit type satellites, consisting of four: LEO, MEO, HEO, and GEO. So LEO is low Earth orbit, HEO is high Earth orbit, MEO is medium Earth orbit, and GEO is geosynchronous equatorial orbit. And this is one of the satellites that we are fond of, which is the GPS, the Global Positioning System, which is also originally known as Navstar GPS. Its function is as a satellite-based radio navigation system owned by the United States government and operated by the United States Space Force. It is one of the global navigation system, GNSS, that provides geolocation and time information to a GPS receiver anywhere on or near the Earth where there is an unobstructed line of sight to 4 or more GPS satellites. Now, I would like to share with you guys my research about advantages and disadvantages of satellite communications. So one of the advantages are, through satellite transmission, coverage over geographical area is quite large, mainly for sparsely populated areas. So in here, we understand that there's a higher bandwidth in satellite communication. Wireless and mobile communication applications can be easily established by satellite communication independent of location. Other than that, security in satellite transmission is usually provided by the coding and decoding equipment. Service from one single provider is easy to obtain, and uniform service is available. Over long distance, it can be cheaper. The laying and maintenance is easy and cheap in satellite communication, therefore, it is best alternative. During critical condition, each Earth station may remove relatively quickly from a location and reinstall somewhere else. Ground station sites are very easy to install and maintain. So from here, what we understand is advantages of satellite communications are their high-speed access, cost-effective, location-independent, bandwidth availability, reliability, instant installation, and deployment. So now, I would like to talk about the disadvantages of satellite communications. The disadvantages are design, development, investment, and insurance of satellite requires a higher cost. To reach the satellite from Earth, time can be between 270 milliseconds and return again to 320 milliseconds. This propagation can delay and cause an echo over telephone connections. Satellites are not easy to repair and maintain. Some circumstances like weather or sunspots affect the satellite signal and can cause interference and make proper operation of satellite very difficult. It requires to be monitored and controlled on regular periods so that it remains in the orbit once it has been launched. So this is the introduction to the universal law of gravitation, which is the gravitational force. Gravitational force is also known as the universal force because it acts between any two bodies in the universe. Gravitational force exists between two bodies, Both bodies experience gravitational force of the same magnitude. Newton's law of universal gravitation states that gravitational force is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. From this diagram, we can observe that F, gravitational force between two bodies, is directly proportional to m1, mass of the first body, and m2, mass of second body. F is inversely proportional to 1 over r to the power of 2. R here is distance between the center of the first body and the center of the second body. As a product, F is directly proportional to m1 times m2 over r2. In 1667, the scientist Isaac Newton observed an apple which fell vertically to the ground and the movement of the moon around the earth. He subsequently concluded that a force of attraction not only exists between the earth and the apple but also between earth and the moon. In the year of 1687, Isaac Newton presented two relationships that involve gravitational force between two bodies, which is gravitational force is directly proportional to the product of the masses of two bodies, that is, F is directly proportional to m1 and m2. The second one is gravitational force is inversely proportional to the square of the distance between the centers of the two bodies, that is, F is inversely proportional to 1 over r2. Kepler law was actually invented by a German astronomist, mathematician, and an astrologist who modified the heliocentric model according to Kepler's law. And he is Johannes Kepler, who worked as an assistant to astronomist Tycho Brahe. His strong determination motivated him to study Brahe's astronomical data. Finally, Kepler succeeded in formulating three laws that describe the movement of planets around the Sun. A line that connects a planet to the Sun sweeps out equal areas in equal times, law of areas. The planet's connecting lines with the Sun sweeps out equal areas in equal covers. In other words, the acceleration of a planet varies according to its position. Based on the diagram, if area of AMD equals to area of CMD, then the amount of time it takes for the planet to move from A to B equals to the amount of time from C to D. All planets move in elliptical orbits with the Sun at one focus point, law of orbits. Each planet moves in an ellipse orbit with the Sun at one of its focus points. As a result, the distance of the planet to the Sun varies so that there is a place where the planet is the closest to the Sun, the aphelion point, and the farthest from the Sun, the perihelion point. Observe that the line AB is longer than the line CD, therefore the linear speed of the planet in AB is greater than its linear speed in CD. The two areas swept out are equal. A planet orbiting with a bigger radius of orbit has a bigger orbital period. The square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit, law of periods. T1 equals to the period of the first planet. T2 equals to the period of the second planet. R1 equals to the distance of the first planet from the Sun. R2 equals to the distance of the second planet from the Sun. K is the constant with the same value of all planets. Suppose two planets have an average distance from the Sun R1 and R2, and the periods are T1 and T2 respectively. Formula to calculate the orbital period T or radius of orbit R. Centripetal force is defined as the force acting on a body that is moving in a circular path that is directed towards the center of the circle. In this situation, when a ball is tied to a rope and it is rotated, the tension of the rope is responsible for ensuring that the ball remains in circular motion. Therefore, in this situation, the tension of the rope is the centripetal force. As a car moves along a curve, the frictional force acting upon the tires of the car is the centripetal force needed for the circular motion. As the moon orbits the earth, the gravitational force acting upon the moon provides the centripetal force required for circular motion.